What is a falling object? The force of gravity causes objects to fall towards the center of Earth. The acceleration because of this gravity is constant, which means when friction and a resistance are negligible, we can apply kinematic equations to these objects. What about the direction of acceleration? The direction of acceleration due to gravity is downward, towards the center of Earth. It is shown by the symbol g, and its value is 9.8 meters per square seconds. But is g positive or is it negative? Note that g can be either negative or positive. It depends on which direction we choose to be positive in the coordinate system. Since we usually take the upward direction to be positive, g is usually negative 9.8 meters per square seconds in physics problems. Have you ever heard of an object in free fall? If an object is dropped with no initial velocity, where there is no air resistance or friction, the object is defined to be in free fall. The motion of this object is one-dimensional and has a constant acceleration of magnitude g. Here are three kinematic equations for objects in free fall where acceleration is negative g and vertical displacement is shown with symbol y and horizontal displacement with symbol x. So this is the first equation for velocity. Second equation for position. And a time-independent equation. To understand these equations better, recall the one-dimensional kinematic equations that I went over in the previous video. These are the equations that we have. We had this equation for v, the equation for position, and the equation for squared velocity. You can see that in all three of these equations, if you replace x with y, and if you replace a with negative g, you will get the kinematic equations for objects in free fall. Because after all, free fall is just a one-dimensional motion in y direction with acceleration negative g. Now let's look at an example from the college physics book. We have a person standing on the edge of a cliff. This person throws a rock straight up with an initial velocity of 13 meters per second. The rock misses the edge of the cliff as it falls back to Earth. Now we want to calculate the position and velocity of the rock 1 second, 2 seconds, and 3 seconds after it is thrown, neglecting the effect of air resistance. So the rock misses the edge of the cliff, so it just comes back down and then goes down towards the Earth. And then we want to find out the position and velocity at t equals 1, 2, and 3 seconds. To solve this question, first, let's draw the coordinate system. I will take the upwards direction to be positive and downward to be negative. So the gravitational acceleration is negative g and the initial velocity is positive. I will take the initial position of the rock, or y0, to be the origin of the coordinate system, so y0 is equal to 0. Now, between these three equations that we just talked about, which one do you think is the best one for solving this question? Think about what we have. We have v0 and we know the value for g. We also do know at which times we want to calculate the velocity and position. Considering what we know and what we want, it really doesn't make sense to use the third equation, since it will only make our solution more complicated. So to find y, let's use the second equation that gives us y directly, and to find v, we will use the first equation. Now that we defined the coordinate system and the directions, and we identified which equations we want to use, it is now time to substitute some numbers into these equations. For y at 1 second, we have the initial position is 0, v0 is 13 meters per second, and we are at t equals 1 second. We know that g is 9.8 meters per square seconds, and this is again 1 second. So this is equal to 8.1 meters. This means at 1 second, the rock is 8.1 meters above its starting point. So if this is the cliff, and at 1 second, the rock has gone up to 8.1 meters. What about velocity? v0 is 13 meters per second, g is 9.8 meters per square seconds, and t is 1 second. This will give us 3.2 meters per second. The velocity is decreasing, as expected, since at 1 second, the object is moving in opposite direction of acceleration. We can use the same equations to solve for t equal 2 and 3. As you can see, the rock at t equals 2 seconds is at a lower position than it was at t equals 1 second, which means the rock has started coming back down to Earth. The velocity at 2 seconds is negative 6.6 meters per second. Note that the velocity is now negative and also a larger magnitude than it was at t equals 1 second. This is expected as the object is now moving in the negative direction and in the same direction of acceleration. Now we can do the same thing at t equals 3 seconds. At t equals 3 seconds, if we solve the equations the same way we did, we are going to get for y negative 5.1 meters and for v negative 16.4 meters per second. Note that the negative value for y means that the rock is now in a lower position compared to its initial position, and therefore it is now in the negative region of the coordinate system. So the rock must be somewhere here. The velocity also is expected as the object is still moving in the negative direction and speeding because it is moving in the same direction of the acceleration. Now, to get a better sense of rock's motion, I will draw the position, velocity, and acceleration graphs. Let's look at the YT graph first. We calculated this before. We know that at t equals 1 second, the position of the rock increases, it goes up and up. At some point, it stops and then starts coming back down towards the Earth, and then it passes the edge of the cliff and then goes to the negative region of the coordinate system and goes towards the Earth. So it goes up and up. At some point, it starts going down and then comes to the negative region of the coordinate system. Let's say this is about the 1 second mark, 2 seconds, and then between 2 and 3 seconds, it starts coming to the negative direction. And at 3 seconds, we have a negative value for y. Now, what about velocity? We know that the object starts at 13 meters per second, and then the velocity decreases and decreases. At some point, the object changes direction, so the velocity changes from positive to negative. and then it starts increasing in the negative direction. And this switch, as we calculated before, happens somewhere between 1 second and 2 seconds. For acceleration, we know that the acceleration is constant and it is negative 9.8 meters per second, so this is just a straight line. So this is about 10, negative 10, and this is negative 9.8 meters per square seconds. I hope this video helped you understand the physics of falling objects. If you'd like to learn more about one-dimensional kinematic equations, check out my video linked on the screen and subscribe so you don't miss my next videos where I will go over the topic of two-dimensional kinematics.